principle of perpendicular axis. Now, principle of perpendicular axis theorem, we have to derive in similar way. Let's see the statement here. Mathematical statement, let I tell you, this is a mathematical statement. Iz is equal to Ix plus Iy. Now, what is Iz, what is Ix, that I tell you by using diagram. So you can see here, we consider plane surface or plane lamina. Now I consider this is x-axis, this is y-axis, and this is z-axis. A body rotate about this x-axis, then moment of inertia of body is Ix. And if body means not a body here, the plane lamina or plane surface rotate about this y-axis, then the moment of inertia is Iy. And if it rotate about z-axis, then the moment of inertia is Iz. So Iz is the moment of inertia about this z-axis, which is perpendicular to the surface. Ix and Iy both are lying in a plane of the body and they are perpendicular. So you can see here, we have to write the statement in terms of this mathematical equation. Iz is a perpendicular axis. So you can see moment of inertia of plane lamina about an axis perpendicular to the plane. This is very important. About axis perpendicular to plane. Then you can see is equal to sign A is equal to. Then you can see this addition of Ix and Iy. So sum of moment of inertia about two mutually perpendicular axes. You know that x-axis and y-axis, they are perpendicular. And they are lying in the plane of the lamina. And intersect, both x-axis and y-axis intersect at a point where the perpendicular axis cuts the lamina. You can see here, z-axis cuts the lamina at this point, and at the same point, x-axis and y-axis intersect. So this is a statement. You can remember the statement by remembering this mathematical equation. Now let's see the proof of this. So we consider a plane lamina. You can see here in a diagram. Now after that, moment of inertia, we have to write about y-axis. So moment of, we consider here small mass element P, which is at coordinate x comma y. The coordinates of this P is x and y. So x comma y, these are the coordinates. Now after that, it means that, so this distance is y and this distance is x. Similar manner, this is also y, then this is also x. So we drawn here a parallelogram or a rectangle, we can see. Now after that, we can write here moment of inertia of element about y-axis. You know that from y-axis, you can see here, this is a y-axis. From y-axis, the P is at a distance x. So distance square into mass. So x square dm is the moment of inertia. Now similar way, we can write here this element word replaced by body, or we can here talking about the lamina, plane surface. So moment of inertia of lamina about y-axis is integration of that. So integration x square dm, and this we can call it as a Iy. So because about y-axis, so we can call it as a Iy. So Iy is integration of x square dm, equation 1. Similar manner, the same wording, whatever we are written here, in similar way, we have to write for x-axis and z-axis also. Y-axis is over. Now, so you can see moment of inertia of element, again the same word, element, about x-axis. So you can see x-axis and p distance, it is y. So y square dm. So this is element word replaced by lamina. Then we can write integration of this y square dm. So, and that we can represent by Ix. The same wording, only the thing is here, x means here y-axis is replaced by x-axis. Now similarly, we can write about z-axis also. Moment of inertia, I'm directly writing for the lamina now about z-axis. So you can see, so z-axis, this is z-axis, and the p distance, this is a distance. And this distance, we are not named by any symbol, so I use OP. So OP is the distance. So integration OP square dm is the integration, is the moment of inertia of this this lamina about z axis. Now by Pythagoras we can substitute OP square. This angle is 90, or this angle is also 90. So if you use this triangle, so this OP square is y square plus this is x, so y square plus x square. So you can see here, so this OP square is y square plus x square, or x square plus y square. So equation 3 we can write by substituting OP square, integration x square plus y square dm. So we substitute OP square only. Now we simplify this, integration x square dm plus integration y square dm. Now this integration x square dm, you can see equation number 1, and integration y square dm is equation number 2. So we substitute both the equation here. So we get the final expression for moment of inertia about z axis is equal to Iy plus Ix. And this is expression for principle of perpendicular axis theorem, which we have to use. This article also many times asked in the board exam, so you have to prepare it very well.